In this video, we will try to intuitively understand what combinations are. The question that combinations ask is, given n items, what are the number of ways you can choose k items? For example, you have a group of 5 kids and we need to form a team of 3 kids. Okay, so how many different ways you can form these teams, right? So maybe you can have a team which has the kids A, C, B, or the kids A, D, E, and so on, right? So the way that we do like all sorts of combinations problem is in 2 steps. First, we use the concept of permutations to come up with all possible arrangements. Okay. And then in the second step, we go and remove any duplicates. Okay. So we'll try to understand this better through an example now. So we have 5 kids A, B, C, D, and E, and we need to form a team of 3. The strategy that we are going to apply here is we will first make the 3 kids stand in a line, right? And then find out all possible ways of making them stand in a line, right? So basically we have 3 kids, so 3 spots in the line, right? First, second, and third. Okay, for the first spot, there are actually 5 possible options. So either A, B, C, D, or E can stand first in the line, right? So once the first spot is taken, let's say B, then for the second spot, we will have 4 options. Either A or C or D or E can take the second spot, right? Once the second spot has been taken, for example, by C, then for the third spot, we will have 3 options, okay? So which are A, D, and E. Okay, so once we build the tree like this, so this is one possible way of lining them up, which is B, C, D, and maybe this one will be B, C, and E, right? So these are all the possible ways we have lined them up, right? So this is the first step. We can see that the number of ways we can make them stand in a line will be 5 times 4 times 3. So this will be 5 times 4 times 3. So this will be the total number of ways we can line them up, right? Once we have lined them up, now the second step is we need to remove the duplicates. So what I mean is, if you see all the possible ways we have lined them up, in this we will see some the arrangement something like B, D, C also, right? So because we need to form a team of 3, either we select the team BDC or BCD. It's the same number of same kids, right? So these group and this group is the same. So we need to find out all such duplicates and remove the duplicates and then count the number of ways, and those will be the number of ways you can form a team of 3, right? So now let's go to the second step. So once we have all different ways of lining up 3 kids, now we need to form the teams. We need to select the teams, right? And then we see that there are some duplicates and we have to remove the duplicates, right? For example, if you want to form a team with kids B, C, and D, this team and the team with BDC are the same team, right? So, and similarly, the team with CDB, right? So we need to collapse all possible duplicate teams, right? So since for a particular team BCD, they'll show up in 3 factorial ways, because those are the number of ways you can arrange them, right? So for a particular team, there'll be 3 factorial duplicates, right? For the team BCD, there'll be 3 factorial duplicates, and for the team CAD, there'll be 3 factorial duplicates, and they'll show up as CAD, CDA, ACD, and so on, right? So this is the second step where we remove the duplicates. Basically, we collapse all the duplicate teams and then count all of them as one team. Now we should not count as 6, we should count as 1. We have seen that total number of ways we can line up 3 kits, including the duplicates, is actually 5 times 4 times 3. So if we collapse all the duplicate teams and don't count them multiple times, then the total number of teams that can be formed without any duplicates is 5 times 4 times 3, and then you remove all the duplicates, which is 5 times 4 times 3 by 3 factorial, and this can be written as 5 factorial by 2 factorial times 3 factorial. Actually extend this in the case of n items, right? So if you have n items and then you want to choose k items from these n items, so what you first do is you first arrange all the k items that you want, and which can be done in n times n minus 1 times n minus 2 times and so on up to n minus k minus 1, right? And then once you have all the possible arrangements, then you remove the duplicates, right? And then we saw that there'll be k factorial duplicates, and then you have to remove the k factorial duplicates, and this is actually nck, or n factorial by n minus k factorial times k factorial.